This is hopefully our final video on indices. And this is not going to be an exhaustive list of problems involving indices. However, there are a few common ones that tend to come up. So I want you to have a look at them just now. So the first one I want to have a look at is if we've got x cubed times x to the power of 7 all over x to the power of 4. Now, with these, this is a two-step problem. We need to be able to deal with rules 1 followed by rule 2 of indices. So deal with the top first of all with rule 1. If I times two bases together, I add the powers, so the base stays the same, and 3 plus 7 gives us 10. The bottom has not yet changed, so x to the power of 4 stays the same. Now using rule 2 of indices, if I've got the same bases, I just subtract the powers. So 10 minus 4 leaves us with x to the power of 6. Next one then is a variation of that. This time we've got coefficients in front of each of our letters. And you'll notice here that we've got two different letters. That's what makes things a wee bit more problematic, but we can still work with it. 9 times 4 is 36. We've got a cubed times b to the power of 8. They're different bases, so they must remain separate. Their powers are unique to themselves. Okay, so a cubed, b to the 8. The bottom has not yet changed. Our denominator has not changed, so 6, 8 to the power of 7. Now using rule 2 of indices, I've got 36 divided by 6 gives us 6. The b to the power of 8 can just stay put. There's nothing happening on the bottom with that. But we've got 8 to the power of 3 divided by 8 to the power of 7. So rule 2 of indices say you just subtract the powers. So 3 take away 7 gives us 8 to the power of negative 4. Notice I've kept the letters in alphabetical order. Now we should know from rule 4 of indices, rule 5 of indices, sorry. Rule 5 of indices stated if we had 8 to the power of negative n, it's 1 upon 8 to the power of n. So I can rewrite this as being with the 8 to the power of 4 on the bottom. Remember, minus 4 goes to the bottom, 8 to the power of 4 is positive on the bottom, okay? However, the 6 and the b to the power of 8, neither of them have got negative powers. They remain on the top, 6b to the power of 8. And just because I love challenging people, let's do the same thing again. This time we've got multiple bases on top and bottom. So again, a cubed times a, well, it's just a on its own, that means 8 to the power of 1. So a cubed times 8 to the 1 is 8 to the power of 4. The c and the b are two different bases, so we'll put them alphabetically first of all. B comes first, so b to the power of 10, c to the power of 7. None of these can be combined, nor should we try to do so. The bottom has not yet changed, b squared, c to the power of 4. Then we've now got a simple case of rule 2. So 8 to the power of 4, there's nothing on the bottom to cancel through, so it remains 8 to the power of 4. b to the 10 divided by b squared, 10 take away 2 is 8. c to the 7 over c to the 4, c cubed. Done. Example number 4. Now, in every example we've done so far, the coefficients have divided exactly. This is not the case here. So I'm going to rewrite this as a fraction instead and see what we can do with it. So I've got 18 m to the power of 9 over 12m to the power of 11. Now we know that m to the power of 9 divided by m to the 11 will give us m to the power of minus 2. What are the coefficients then? 18 and 12, they don't go in exactly. However, they're both divisible by 6. So if I divide 18 by 6, I get 3. If I divide 12 by 6, I get 2. I'm left with 3 upon 2. So 3 over 2. And you notice how the m is not part of this fraction here. It's at the side of it. The 3 upon 2 has become a coefficient. However, we do know that if we've got a negative power, this should go to the bottom of the fraction. So we can rewrite this as being 3 over 2m squared. And our final example then is this one here. And this is employing an idea where we're just breaking brackets. Notice that inside the brackets it's not a times sign, this is a plus. Now plus we've not dealt with. If we're just adding two bases together with different powers, they just stay separately. We cannot combine these at all. So all we're going to do is just break the brackets straight away. We've got 8 to the 4 times a cubed plus 8 to the 4 times 8 to the 5. That should be easy enough. This is just two lots of rule 1. 8 to the power of 4 times 8 to the power of 3 is 8 to the power of 7. And 8 to the power of 4 times 8 to the power of 5, add them up, 8 to the power of 9. And we leave it as that. We do not combine these powers at all. I'm going to add one more in, just to irritate you. Let's say we have b to the power of 1/2 b plus, let's make it b to the power of 1/2 plus b to the power of minus 1/2. Well, following the same rules, we'll times these two together first of all. B to the half times b to the half plus b to the half times b to the negative 1/2. Well, we know that a half plus a half is just 1. And a half plus negative a half, well, if I add a negative number, add a negative number, that's just the same as taking it away. So that's going to be a half, take away a half is 0. We don't ever write b to the power of 1, we just leave it as b. And remember, anything to the power of 0 just becomes 1. b plus 1, that's us done. Loads of examples for you to try, folks. Give as many of these a go as you possibly can just to master them.